1.6 geometric sequences. What a geometric sequence is, it's a sequence in which the terms are found by multiplying a preceding term by a non-zero constant. We have only been dealing with arithmetic sequences. We are adding on a constant every single time. These are geometric. Looking at the sequence, 3, 9, 27, 81. Try to find a pattern. What's happening every single time? It's multiplying by 3 every time. So when I'm multiplying by 3, how did you get that? Just by looking at it? Now the way to actually sit there and figure it out though, how are you getting the 3?
Use up 1 times n minus 1 times use up 1. I don't know.
Taking u sub 2 dividing by u sub 1. Taking u sub 3 dividing by u sub 2. Taking u sub 4 dividing by u sub 3. You're dividing the one that's divided by the one before it. So this one, the difference is 3. What about for this one? Every time here, the only thing is changing the denominator. What's happening every single time? It's multiplying by 2. So it's the denominator is, so it's the difference is multiplying by 1/2. So this one was multiplying by 1/2. This one was multiplying by 3. The recursive form of a geometric sequence is u sub n equals r times u sub n minus 1. R is your difference. It's what you're multiplying or dividing by each time. So if we go back to the first one and we write the geometric sequence to find out what r is. To find out what r is, we just took 9 divided by 3, which was 3. Just to show you the other one, 27 divided by 9 is also 3. So the recursive formulas, u sub n equals 3 times u sub n minus 1. That's for, D stands for arithmetic, the difference. R is the geometric. All I have to do is just take the term and the term before it to find the R. And the one thing I'm forgetting here is n is greater than or equal to 2. How about this one? What's u sub n? Half u sub n minus 1, as long as n is greater than or equal to 2. We're going to find the first 5 terms of a sequence if the first 2 terms are 2 and negative 2/5. All right, just by looking at this, I got to find out what r is. That's the first term, that's the second term. So I'm going to take negative 2/5 divided by 2, which I'm going to do it by hand. Negative 2/5 times by 1/2, which is negative 1/5. You can do it in the calculator, you still get the same answer. Got it? Simplified. 2, 2, 1, 5. So it's u sub n equals negative 1/5 u sub n minus 1, as long as n is greater than or equal to 2. And the one thing you also have to do is when you're writing the actual sequence is to say u sub 1 is 2. I keep forgetting to put that on the end. So if I gave you this information, you could tell me the entire sequence. I could tell you what, you could go and tell me what 2, 3, 4, 5, 6, what all the sequences are, or all the terms of the sequence. Without that u sub 1, you can't find anything. Explicit form. Remember, Recursive has the u sub n and the n minus 1. Explicit is a little bit different. You need u sub 1 in the problem. Explicit formula is u sub n equals u sub 1 times r to the n minus 1 power. If I look at this one and I want to write it explicitly, remember this is recursive. Now we're going to do it explicitly. Explicitly still is u sub n equals. What's my first term? 3. That's what's my r value? 3 to the n minus 1. As long as n is greater than or equal to 1. Looking at the second one. This one was the recursive one. For the explicit one, u sub n equals, what's my first term? 5 halves. What's my r? No, my first term is 5 halves. It's 1 half n minus 1, as long as n is greater than or equal to 1. I will go back to the last one. Same exact problem that was on here. Except for now we're going to write this explicitly. So explicitly, u sub n equals, what's my first term? 2. What was my difference? Negative 1/5, not my difference, my r. And it's n minus 1, as long as n is greater than or equal to 1. For our partial sums, these are your summations. The formulas change. Actually, it's just one formula. You have the summation from n equals 1 to k. U sub n equals u sub 1 times 1 minus r to the k over 1 minus r. We're going to talk about the bouncing ball from lesson 1.2. Here's the problem from 1.2. A ball is dropped from 9 feet. It hits the ground and bounces to a height of 6 feet and continues to bounce on the rebound as it rises to 2/3 of the original or the previous bounce. So we're going to use this formula or this problem to answer this question. How far does the ball travel when it hits the ground for the 7th time? You can rewrite this that way you have it. U sub n equals. Now we got to figure out what the formula is first. U sub 1 is U sub 1 is 6. U sub 0 was 9 because we haven't dropped it yet. Okay. Now, what's my r? Right there is my common ratio. So I have 2/3 the n minus 1. Now all I have to do is 6 times 2/3 to the what power?
Third. 7.
Be a third.
No, if it's 7th, I need to put 6. Why 6? N minus 1 to the 6th power. That is how high the ball has bounced. But if we read, it wants to know how far has the ball traveled. So that means the total of up, down, up, down, up, down, up, down, up, down. So that's the summation. So we'll use the summation. What was the first term? 6 times 1 minus 2/3 to the 7th bounce over 1 minus 2/3. U sub 1 is 6. The common ratio was 2/3. We want the 7th bounce. And we just type it all in. 6 times 1 minus 2/3 to the 7th. That's the top. Make sure you're putting the 2/3 in parentheses. Divided by the bottom. 1 minus 2/3. It traveled a total of 16.95 feet. I think it was feet in the original problem. Feet is 1 slash. Inches is 2 slashes. Remember the importance of labels with the 3 plus 4, or 5 plus 4 equals 3?
That's exactly what I
Any questions on this section?
Wait, do we have to know which explicit formula to use for which?
There's only,
3 things.
you'll have to know the arithmetic and you'll have to know the geometric. Correct.